Hey everyone. Hey, hello. Thanks side effects people for inviting me. This is amazing. I see a lot of friends in the crowd. So this should be interesting. So here's my thing, with the theme of the entire thing. So what I've been working on with my team is this kind of thing. So it's a motion from conversation service. And we have built it with the Houdini on the backend. So I want to be telling the story about how and why we build it, about how it works, about how you can use it, and I want to answer a lot of questions. So if you feel like interrupting, then please do, because it's nice that when it's more of a conversation than a presentation, one kind of broadcasting. That's me. So yeah, I've been doing stuff since a very long time, maybe. And I was in Pixelmonde, I was in Scanline, I was in Screen Scene. Then I started my own company, Bottleship VFX. We've been doing feature film work mostly, but then eventually, jumped to Houdini from Max to Houdini in 2019. And when things went a little bit, dry with the feature film work, we said, okay, let's try to figure something out with the ideas that we had. And one of these ideas was Cairos that I'm going to be talking to you about today. This is our website that you can check out, because the thing is a web service that you can access from the website. There is a login button. It's not made for mobile yet, sorry. You can see some demos over there, etc. We've been working more on our Houdini integration lately that we are going to touch on in a second. So the idea here is that we want to synthesize choreographed motion, and you are able to talk to an agent. The agent is going to search a database of motions. It's going to retrieve this sequence of motions. Then a sequencer is going to put these motions together, and the result is going to be a choreography then that you can use for some complex motion. And this database is getting continuously updated by the team that is capturing the motion. So there's these several pieces to the pipeline. And maybe my most worthy, I promise, slide is basically why kind of the whole philosophical part of the thing. And this maybe is something that is spark questions, and it's definitely something that we can discuss. So just the idea, the whole thing, the whole AI thing showed up, obviously. So where are things going? The way that I want to think about it, what I figured is that these companies, the AI, the Metas, the Googles, the whatever Alibabas of the world, they don't see us as their customer, because they want 100 million, 2 billion customers. So they don't benefit from putting into this kind of software lots of sophisticated controls. So there is no cinematography controls, nice shape controls. They steal all of the stuff that we have been doing. They are ruthless about it. They are above the law, obviously. So eventually, they're going to try to make everything happen with the prompt by the user, to bypass us entirely. But this is not going to work, I think, for all forms. Yes, for memes and for TikToks is going to work. We'll see how much of all the entertainment / culture / art we consume is going to become TikToks. It's a little bit sad, but obviously a large part. But then eventually there would be all the other types of media, like the longer, more meaningful types. I'm not saying that these are going to be majority or huge or anything like this, but I think there is going to be a part like that. And when the whole bubble deflates, so when we say, okay, there's not going to be the entire, value chain captured by the big companies with their user-generated content, tech, there's going to be a breed of smaller companies which are going to take this research that has been done, and they will be okay with having 1,000, 10,000, 100,000 customers, professionals as customers, and they're going to build some interesting tech. So that's where I want us to be at eventually. And I think this is an optimistic vision for the future that is going to enable the AI to not replace people who create, and the message and all the humanity that is, the meaning in all of these culture that we make. But it's gonna give you teammate. So just like when you are director on set, you create great stuff because you're surrounded with people who are great. I mean, they're humans, obviously, which is better than machines. But you have help. So there is a great carpenter who can build your set. There's an actor who can source from his training and his background. There's a cinematographer. So you together create something which is great, and you have a lot of stuff ready from nature. So you can go location scouting. You can find a great place, which is great, because the nature made it so. So this is very different from the way that we usually do virtual content, where everything is painstakingly created from the ground up, from zero, obviously making things very slow. And yes, it is expensive, which is not bad. The whole making things cheaper and cheaper is not really inspiring. But I think what is inspiring is that it is impulsive. So to get to a place where creation becomes more impulsive, I think is a noble goal. And not just cheaper, which is not a great goal to have. So getting the creation to be more impulsive, I think, is something to strive for. So, like after that philosophy part, here is our implementation. So what we do is that basically the way it works is that we capture these. First, the idea is that everything which is meaningful that you have for motion is a choreography of a few basic motions. So this means that we can capture, but it doesn't make sense to capture 3-5 second motions, obviously, because this is not how people act. You can't instruct a performer to act for like 3 seconds something out. So you capture these 3-5 minute performances, we splice them up into segments, we label these segments, and we embed them in the vector database that the AI can then pull from. So what this means is that it has the following pros and cons. First, there is a high quality of the motion. So there is zero slop. Everything that you're going to get from this agent is the full quality of the motion capture that was being performed. So we don't really sample in between the samples. That's why I was asking earlier. With the images, you sample the space, and kind of the space in between the samples gets an interpolation. But this might work for images better, but for human motion it doesn't, because the meaningful human motion is so this latent space is very, very sparse, which means that most of the data in between of the coordinates in between the samples that you have recorded doesn't make any sense. So we just said, okay, so screw that. We're just gonna pick directly from the samples. So we're just gonna retrieve, and we're not gonna try to infer, which means that we also get some benefits. So yeah, the motion is complex. We have recorded from a human. We do not have any expensive training for a model, which is dropping significantly the operational costs. We just do an embedding that we take all the descriptions and we create a vector. We basically populate a vector database with them, which is the semantic space. So anybody who has watched Enzo's talk earlier this is gonna probably correlate. This is the same thing. And the inference is also very cheap. So all we do is that we ask the language model to pick something up from this database. Yeah, you get the benefit of having the conversational interface with it, but the inference is extremely fast. And then from then on, what we get from the inference is basically a list. It's a JSON that instructs the sequencer to pick motions up from database and do all the rest of the stuff. So this is the splicing of the motions together in a sequence, maybe masking. So if there is one motion for like one part of the body, other motion for other parts of the body, there is some masking. There is retargeting. So all this stuff is happening procedurally on a Houdini in the backend for us, which is guaranteeing much better quality and much lower operating costs. Of course, because we have Houdini in the background, this means that we can do other cool stuff. So let's say you want to do some Otis on your character, so it gets muscle and tissue, etc. simulation. You can do that, while none of the competing services are going to be they're not going to get this from a direct inference from the AI model ever. I mean, or whatever they'll need 100 billion supercomputer to do that. There are some cons, which is, for example, that the interaction with the environment is going to be challenging. So we rely on the data that we have recorded, which means that if you want to pick up a cup from a shelf which is a little bit higher and not from the one that we have recorded, this is not going to come straight from database, and there is no way to instruct the agent to do that exactly. But integrating with software like Houdini or anything which has animation capability makes it so that you can use these animation capabilities to just edit the motion to adapt to this different environment, which is a much smaller task than creating the entire complex human motion. So this is where it makes sense, where it's efficient to have these extra tools on top. And exactly the Apex toolset that is now showing up more and more in Houdini is the perfect complement for this approach. Of course, scope of motions is limited to what exists in a database, but I think even people who are like, we have some competitors who are doing stuff, in a different way. They basically try to infer the motion directly. The latent space is so sparse, so the nice looking motions are so few that if you don't have something which is very close in the training set to what you need, then you're not going to be able to infer. And one of the pros that I have forgotten to mention here is that, ethics-wise, we are clean. So all of our data is captured in-house, is licensed to us, we are licensing it to you. There is no stealing. While, some of our competitors, the way they are describing it, they say, all the motions that you're possibly going to need, they're out there somewhere. So if we pick them up from there, recognize them from video, but this means that they have stolen it. So this is obviously a problem. While we do not get any of these issues. Okay, so then let's see how actually it works. So we have the capture first, obviously. So, we are a small team, early phase. So it's kind of humble. You're not going to see, like a captures on an arena with Taylor Swift or anything like this. But the thing works. So we have done through a bunch of tests on what gear to use, and we ended up with an Xsense just because none of the other more affordable solutions were having a high quality, and most of the other higher budget solutions didn't give us enough of a quality increase to justify the cost. So we went with Xsense. We got some witness cameras to have some visual context. So when we look at the 3D motion, we know where it came from and we can compare. We inherited a database for project management from our VFX company. Shotgun, basically, like most people know. So we just adapted it to what we need and to be able to stack the capture in there. And we enriched the data that we put in the database with everything that we have from the session. So we know which actor performed it, we know when, we know the bunch of files that were coming with the capture, pre-processed, unpre-processed, so everything is there in the database. If we want to go back, we can, for example, reprocess the raw capture files to solve some issues, stuff like that. So the dataset looks like this when you see the publish. There is some more fields which are text fields that I can open up maybe, but they're not too visual, but still at least, you can see that there is a bunch of, file paths to these extra files. So there is a motion on the left that is a skeleton that doesn't use any retargeting. So this is just the proportions of the pieces are the same as the ones on the capture skeleton, so it does not need to retarget. So there is no any change that is coming in from that besides the motion capture, it's the most raw form that there is. And on the right side, you get the couple of witness cameras that we had on set, just so we can compare, and if we have to go back, we know what to do. Eventually, if things get more advanced, we can use this material for training. And when you have the witness cameras, the 3D, and the skeleton files, you can feed this into a training pipeline that might get something interesting, out of. So we process these raw captures, and like I said, we splice them up into regions, because the practical thing to perform are these longer motions, but then you can get regions which are these individual small, kind of constituted motions. You can label them with both humans and machines, and then they can go into this database. We don't have a finger capture from the Xsense, so we just do an animation pass on top to do some, again, all this stuff is also happening in Houdini, to get some motions, finger motions, just animated from a library of poses that we just blend in and out. But even when the Xsense is giving us great quality, which is most of the time, this is one of the reasons that we picked it, that is that it requires very little cleanup after. So we just go in and we can retouch the animation with an animator that is looking at it, etc., manually, which is guaranteeing quality. And then you can also revisit it. So if there is some issues still left in there in some important motion, we can just go back, version it up, and clean it up. So then we have, so this is our database. Then we have the backend. So the backend, kind of our traffic controller, which means that there is a request from users coming in, and then the backend is creating the tasks. So it's written in Python. Eventually, might get written in Go if necessary. We'll see. There is a RabbitMQ, which is which hooks up to Houdini, and tasks are getting executed, because the stuff like sequencing, etc., is happening in Houdini. And we have a Postgres database that is just storing everything that we need, users, or whatever, everybody's inputs, outputs, everything that we need, database wise. So to do this, we need to run Houdini as a web server, which also defines some methods to work with the particular scenes. So obviously in this case we have like one interesting scene that is doing these interesting things, and we wrote a fast API wrapper on Houdini to have a UV current server that is giving us methods to call specific top nets in the Houdini scene, or to change some parameters. And this is kind of all that the Houdini server is doing. So these are different networks, top nets inside that we execute, and it's a bunch of stuff. So we can ingest like a character from the user in any format that Houdini can read, USD, GOTF, Alembic, OBJs, etc. If you send us an FBX file, then we can also use your skeleton. If not, we actually creating automatically a skeleton. There is a great open source project that I have to remember the name of, but Source, I think it's called. There is also an implementation in Houdini. It was done by some DNEG people that is giving you skeletons. So we use this as a base, but we added some stuff on top, kind of following the same logic to also be able to do the fingers, because it doesn't support fingers. So this is giving you a skeleton. And then when you do the animation, we have sequencing of the motions using KineFX and motion clips. Maybe it would be smart to transfer this to Apex for performance. We have retargeting to the new character from our internal working skeleton. And the sequencing, export work, etc., everything is done by tops to execute. And something fun is that when you want to use the user's skeleton, then you need both a matching pose, which we can say, okay, this is up for the user, to create a matching pose. But we need a correspondence between the name of the joints of our work skeleton and your and the user skeleton. And we just ask the language model for that, because it turns out people name their skeletons mostly in some meaningful ways. But ours is called, let's say, left underscore foot, and yours is called foot, camel case foot L, for example. So this is enough for the language model to give us this correspondence, which is very cool. And finally, at the end, we just export stuff. We have a bunch of export targets, FBX and BGO for Houdini, and like every integration get its own export target. So the vector database, which is one of our AI components, is using a 1300 dimensional space, which is a little bit more than what you might expect. But for this semantic encoding, you need basically lots of dimensions, because the language is quite rich. So you need to be able to to get to some kind of a meaningful comprehension, you need plenty of dimensions. But because we just encode text, the descriptions of the motions, we can go pretty wild. So this is, even with 1300 dimensions, it's still very fast. We can go even crazier if necessary. And eventually, these description of a motion, it becomes a coordinate in space. So then when you talk to the chatbot, what the thing that you're asking for is also becoming a coordinate in space, and you can just pick up stuff which is nearby. So it becomes quite straightforward, for the agent to retrieve. So the agent is the language model, but there is a bunch of tools that they use. So sometimes, when people see, okay, ChatGPT, they say this is the language model. That's not exactly the case. So there is a bunch of things that are built on top of the language model. And in the case of services like ChatGPT or Gemini, you can just, obviously use Google's work for that. But when you have to make your own, you use something like LangChain. So this is a framework that you can write an agent with Python, and the agent is stepping on the language model, but you add tools like the chat history, the database search, the vector database search, where we embedded the motions. For example, previously created table of motions, because this is what the agent is pulling from the database. A bunch of things. So basically, give it tools that it can use to get the task done. And then at the end, there is the front end. So this is what the user interacts with. So there is a web app that is looking something like this. So just ask him here to, earlier, just before the talk started, I said I am at a presentation, impress the audience. So he said, okay, I'm gonna perform something, and then he said, first I'm gonna lift my right arm high in the air to catch some attention, and then I'm gonna give a presentation. Which you see, like, I didn't ask for anything specific. This is all something which is kind of magical and cool, that you can be very, very loose, and you can say, okay, give me ideas. So for situations where you are, for example, you're making a crowd system, or you just want to use humans as something which livens up something, the fact that this can just give you ideas and retarget it to a bunch of characters would be very handy. And then ask for some changes. Okay, I like this, but can you also point to something on the other side? So he added a motion to the sequence here that responded to what I need. Like, asked, you have pointing to something on one side. Can you point to something also on the other side? So he added some motion also there. So this is our web app, but there is also a Houdini integration that I'm going to be showing. Let's say, for example, here I wanted to get my machine's remote working, but I didn't manage, unfortunately. So I'm gonna show you. Yeah, this didn't really work. Let me find it. Sorry. Our YouTube channel basically has some tutorials. That's annoying. Just a moment. So you get an HDA like this that you can use to log in and then request motions, because the whole thing is happening on the web service in the backend, and you need to log in. But then once you logged in, you just enter your prompt, and you're gonna see that there is a console with kind of what you asked for, what motions were retrieved, what the backend is doing, and your replies from the agent. And it takes a few seconds for this. I think somewhere like 5-10 seconds or so for the motion to be retrieved, and you're going to be previewing it with an Electra, or you can preview it with just a skeleton or our own or the character that was used for the capture. And from then on, you can move on to retargeting it to your character. So here, for example, I have a simple character who is coming from an AI prompt, and this is what we have tested quite a lot, because we did not have character artists on the team at the time. So getting these AI characters was quite handy, and we have the Cairos animation. We have the USD character coming from the AI. We ask Cairos to create the skeleton and the weights, which is again something that is like I said, something that is running in Houdini in the background. And we can get a retargeted animation from Cairos, but you can also get animation. You retarget the animation in Houdini, which is obviously something that I would imagine people will be doing more of the time. That allows you to edit the animation at will. I think this is in the next video. So yeah, there was some issues here with the animation, that the shoulders were a little bit too close, for example. And when you do your retargeting inside Houdini, you get a lot of tools to adjust the animation. Like earlier, I was saying that the Apex especially is giving you all of these extra tools that you can even create extra rigging components and do some extra animation. So here it's quite simple FK changes, but they could be IK changes that you can make it hold something in particular or whatnot. Transition to a ragdoll, all of these Apex crazy stuff that you see. We have a hand poser, so I used this thing here to give it metal concert vibes. And yeah, this is quite straightforward. Editing the animation is quite straightforward, and then it goes to Solaris for rendering. So Houdini integration is quite established for now. But besides that, we have an API. So there is an open API specification for the client, and you can generate for any language wrappers that you need. So if you want, I think we have like a Python, we have a TypeScript. So if you want a, I don't know, like a Rust client, you can generate one. Okay, I think I was explaining mostly about the Houdini integration. And Apex is generally making things a little bit more interesting, because it has a lot of tools that were missing in Houdini until now. So things like layering the animation very easily, like cleaning up the keys coming from baked motion capture, transitioning into other animations very quickly, the ragdolls, and especially the super high performance rigs that you can have crazy stuff in there, and you can get very high performance. So this is very cool, and playing with Apex on top of Cairos was very fun. But then Epic opened the MetaHuman, which makes things even more interesting because, then you can have high quality, easily created parametric human bodies, and they get imported into Houdini as an Apex rig, and this makes things even more interesting. So what we did was to add a service to Cairos, which is something that that is happening here. So this guy, so basically this service is saying that, let's say you have all of these AI characters that you have tested things out. So if you go to the website, there is a bunch of tests. So for example, there is this guy that has a little bit of Houdini on top to give him the shovel as a prop, and then place it in the hands correctly and match this motion. But there is like this capoeira fighter. There is the Lara Crofty kind of character here. There is our wizard, or like there was here like a Dalsim inspired and a Braveheart inspired character, whatever we could come up with. But obviously, these guys are very easy to come up with, but the problem obviously is that once you want to do something a little bit more fancy with them, you're gonna hit the wall because they don't have hair grooms, they don't have CFX, like they don't have even their clothes are the same mesh as the body. I think we have a video for that. So this is one example, and I think this was actually before we replaced the body with a MetaHuman. But you can see obviously the issues that the asset is generally cool, but the details don't make too much sense, probably because the iterations are not enough on the variational autoencoder, but decode step. But anyways, we have a character with all its with everything in there, but it needs a rebuild basically. So what we did is we say try a bunch of options, and then when you have something that you like on the crude design front, submit it to the service, and then the service is going to return something to you, which is a MetaHuman body. It has clothes that are being rebuilt, with Marvelous, with ZBrush, etc. There is a person who is doing that on our side. There is a groom which is being done, for hair. And there is a CFX setup by a person who has done, the Vellum stuff that you need to do. So when you process it, it's going to give you good-looking CFX, cloth. So eventually, when we then animate it with Cairos, we get a result which is a level better. So you can see, and this is again something that is in Houdini. So the MetaHuman is coming in. The MetaHuman is a part of the Cairos character. So the Cairos character is getting read in, the MetaHuman is getting animated with Cairos, the animation gets retargeted with Apex on the MetaHuman. There is some changes done on top where you want something to be a little bit better. So for example, in this one, I wanted to lift the forearm in some places so it doesn't go into the skirt as much. I run the simulation for Vellum, for the cloth and for the hair. Then transfer this animation to the render geometry, and it goes to Solaris for rendering. And you get something which is very quick to come by, but it's pretty decent quality. So this would work out for everything, but the highest end production out there. That's also something that we want to pitch with people to see if they would like it. I thought I'd do live demo inside Houdini, but I couldn't make this on time, get the remote connection already installed. But at least, yeah, you got the live demo with the web app. So if we start a new conversation and we say, what should we say? Eldad, what do you want to say? Sorry? Drink some water. Okay. Drink some water. I can be as dyslexic, Shahin, as you like. Language model is okay. So in a few seconds, I get first the answer from the agent. Sorry. So the agent is saying, okay, I looked into the database, I found this, and then I'm going to send this to the sequencer, and the sequencer is going to do its job to, retarget the motion, like do all the rest of the work, and that's what I get. I mean, the guy is in a cafe or like drinking water, sitting down. So then I can continue. I can say, okay. Yeah, I can ask, like, this is the cool thing about the conversation. Okay, say, okay, generally the right direction, generally okay, but can you drink from a bigger container? You also get an ID for the motion. So this is directly traceable back to the database. So all of these motions that, for example, also over here were listed, which means that if you say, yeah, I found this motion with this ID, but it's not really, yeah, I mean, it's close, but, can we do something about it? We can simply open this up and we can do something. We can do something to make this a little bit better. So you get, I mean, it's drinking like in a different way. It's maybe not exactly what you meant, to if you describe it in more detail. So like say you're drinking from a barrel, so you have to kneel down, and the more information you give it, the better it becomes. But the cool thing is that it always is good. I mean, it's good in different ways. But it always is good because we just pull from the data set directly. So you don't get guaranteed it to be exactly what you imagined as a result, but it's going to be a good result. And then, for characters who are not your main character in your film, and characters who are adding life to the entire thing, it hopefully is gonna be helpful enough. It's not too slow also, so I can now call retargeting. But you see, this is something that is now running on a single machine somewhere on the Hetzner cloud. It costs us 50 euros a month to operate. So operating costs are very low. Even when you get a lot of users, the costs are going to scale linearly and not exponentially. So it's pretty efficient. We have a subscription system that is running on top of Outseta, which is just a service that you get. But nowadays, what we discovered is that it's easier for us to build things than to sell them. So obviously, we're not great salespeople yet. That's a talent to still be developed. So what we do is that we will make it as free as possible. So I think we now switched it to 200 credits per month free. So you can go in and you can do 200 things in a month and it's going to be free. If you want to do more, then you have to subscribe. It's like 20 per month to subscribe. But we are looking at ways where this work for ways for this to make money. Currently, we have stopped our data acquisition process. So when we get some revenue, this would be one of the first things to restore, because the system is strong when you all the time add data to it. But yeah, try this out. It's it's generally free or very affordable. It stops becoming free after quite a lot of use. And check out the website. There is a page where you can say getting started with different ways. So there is the website, the web service, or Python, or you can start with Houdini. There's instructions how to download the plugin, how to install it, and then there is a bunch of tutorials. You can email us, ask for support and anything like this. And yeah, just enjoy for now. Let's see where it goes. and if this can become useful. So that's pretty much it. These are my the first thing is the website again, and the second is my Linktree. If you guys want to get in touch, I'm everywhere. So yeah, thanks a lot again for the invite, and questions are welcome. Awesome. Question.
Thank you. Thank you for the presentation. I like the bit about the philosophy at the beginning. I think I'm in line with you there. The question I have here is at the end there, when we did a little bit of a test demo with the two people at the front, you said again it's pulling directly from the database, so it's going to look good. Which
as
is
good as the database.
Yeah. It's a little bit like how MetaHuman have sliders that weren't didn't let you make a non-human face at the beginning. Is the resulting motion really always entirely pulled from the database, or is it or do you have a model that actually blends multiple motions from the database?
No, we don't yet.
Okay.
So the idea is that we would start with only the retrieval, because it has all of these many benefits, and then when we have capacity or the right opportunity, we would get somebody like Enzo here, give them data set, and then see what we can infer from this data set. There are interesting opportunities in combining different methods. So, for example, there could be stuff that you could use the data which is in there for a start, and then get something else on top that is, let's say, for example, you have an FK system that you can control with a language model, which is basically the IK or the FK system has a bunch of parameters, and you can teach the language model how to fill these parameters out, and then you could do a two-stage system with the motion capture pulled from the database as the first level, and then the language model interfaced IK system as a second level. And you'll be able to say, okay, lift your hands, for example. You can say, okay, this is the cool. Can you just lift your hands at the end a little bit? That's obviously something that can be done with an FK system even, but we just need to have a language model interface for it. And that's something that we have actually experimented with, and it works. It was a different situation a little bit, but we have a grass generator that we used in a bunch of VFX projects. And just like other generative stuff, HDAs, it produces very cool results, but it has a lot of parameters. So it's not good for untrained people. But you can tell the language model about each parameter, and you can describe what needs to go there, what range is it at, etc. And then when a person does a very trivial prompt, it's going to be able to fill out all of these parameters. So we tried something like make a grass which is like springtime in Bolivia, and it knows how tall it should be. It knows how much yellow, what the mix of yellow versus green should be. It knows how much kind of grass versus flowers there should be. So it fills out all of these parameters automatically, as long as it's prepared well enough, and you get a language model interface for a procedural system. So there's something that we can definitely add as a layer on top of this. I think we're going to be showing this off in a couple of weeks, just as a test to see if people like it.
Great, thank you.
Other questions? Yeah.
Hey, great talk. I'm just wondering, how much time does it take between the moment where you have the animation and the moment it's available in the pipeline? What's the bottleneck, and how long does it take?
So it's the next day or the day after the next. Because when we did this, we had 3 people on the team. So you have one person who is the director, one person who is the technical person on the on the motion capture, and you have another person, or actually had at some point 3 interns who are doing the processing, labeling, and publishing of the motions. So this is scaling very well because we have built all of the HDAs in Houdini, and it's easy to train people how to use them. So you can get pretty junior people to be able to do that. If you have lots of capture, you can have more people processing it. But I think with 2 or 3 people, we managed to process the entire day's worth of capture for 1 day. So you capture on day 1, day 2 is the processing, and on day 3 it shows up in a database.
Nice, thank you.
Anyone else?
And it's not stolen.
Yeah, cheers. It's great that it's humans. Are you maybe considering like animals, cats, dogs? They don't have to drink tea, but like...
Why? Don't you like your cats drinking tea? I mean, this is London, obviously.
Just the scope.
Yeah, we could do that. We went with the humans just because with the motion capture gives us a good way to quickly acquire lots of data. But obviously, if there is, for example, if somebody comes to us with a data set that has cats and dogs and tells us, let's do something like this, we can use their data set. Or we can start producing a data set like this. We can figure out, budget what it would entail, and then we could do that. But we optimized our resources in the start. So this was the kind of the quickest route. It's technically possible.
Nice, thanks.
Have you looked into trying this with crowds? Seems like a natural fit for crowds.
Yeah, there is a test we are working on with Imre. So I think Imre was on your beta, right? Okay, so he was on Rafael's beta. He obviously is a guy who is curious. So yeah, we're working on something like this. I am quite versed with Solaris, but I haven't done crowds yet. So I was digging through, how the agent and the deformation and everything happens. There are some things there that were that I felt, should be better or could be better, like the way especially that it comes in, the way the shaders are working. So there was not like the MetaHuman, for example, was coming. We can only get in with SOP import, which was creating the shaders automatically, but we couldn't sublayer then just animation on top of it later. So there was a couple of technical things, but absolutely for crowds, this is going to be very cool. And yeah, with Imre, we're going to come up with a test, I think.
The other area that I think would be really neat is games. Especially with MetaHuman, but they focus a lot on sort of clip-oriented things that could be really interesting.
Now we have a test client that I'm going to be meeting next week that they are not using Unreal. They have their own engine, but they're interested in using something like this as a placeholder animation just because they have so much material in the game that they want to populate very early on. So then they can focus on the pieces which do matter, which is the same thing that you do in VFX, right? Like you first build everything out so it's feature complete, and then you start designing. So they want to do the same thing. So to have their world full of motion, and then start giving the tasks to the animators based on priority. So maybe some of the motions they would not ever need to be touched. Some of them is just going to be just left as it is. Others they would be integrated. They would be edited with something like this. And some other ones, the animator is going to decide to replace completely. But still, it's going to let them triage it. So the animator is going to focus in the most important places, and the rest of it is going to be filled out by a system like this.
Very cool. Great presentation. Thanks so much for taking us through that.
Thank you. Thanks again, everyone.